Hi gents, welcome back to our 2015 question here. We're going to do the B part out. Hopefully you found the A part okay. We'll now just get rid of it, I suppose, as much as it would be nice to have that for another time. We'll just give ourselves some space to the B part. Okay, it says a woman falling vertically by parachute in a steady downpour of rain observes that when her speed is 5 meters per second, the rain appears to be at an angle of 45 degrees with the vertical. When her speed is 3 meters per second, the rain appears to make an angle of 30 degrees with the vertical. Find the magnitude and direction of the velocity of the rain. Okay, this is actually quite similar to the ones that we did in the book. So hopefully you're actually okay with this. I would think that this is not too bad. The trick with this one here is you start off and you say that the velocity of the rain itself, you give it a name. So we'll call it xi plus yj as is traditional. And we'll start off with the one who is falling. Since she's going straight down, she's not going left or right, but she is going straight down and she's going down 5j units. So that's fair enough. And what we want to do here is we want to say what is the rain relative to the woman, because we've been given that piece of information. Well, we know that it's VR minus VW. So what we want to do is we want to start with the R value and subtract off the W value. So it's going to be x minus 0, so it's still xi, and it's going to be the y value. And then you're going to subtract minus 5j. So minus a minus 5j, we're just going to have y plus 5j's. Okay, that's what that is going to be. Now, if you actually, you know what we'll build up our two separate cases, a little bit like out of the book, and then we'll worry about it in a second. Okay, second case. So the woman notices that when she's falling at 3 meters per second, so same thing, she's just on the way down, but by 3 meters this time. And whoops, sorry, the same thing is going to happen here. What is the rain from the perspective of the woman? It's going to be VR, which was still up here, minus VW. So VR, which is x minus 0, still xi. And then it's going to be y minus a minus 3, so y added to 3 amounts of j. Okay, that's what we have. Now we're told two things here, so I'm going to try and just draw a rough diagram of what I think the question is asking. What it's saying is that in this first case here, it appears to be from the vertical 45 degrees. Okay, that's what it is doing. Okay, like that. So what would I take this to be here? What I would take this to mean here is that my x value should equal my y value. You can even actually do it out here. Maybe it might be a little bit better. Really have to get better at doing that, I apologize. So for instance, if this was minus 5, this would also be minus 5. That's how it would make a 45 degree angle. Okay, so we're just saying whatever this x value is here must be the same as whatever that value is, including the signs. Okay, they're both negative if you like. So, you know, if minus 5 equals minus 5, then 5 is 5, whatever. So we'll just here be able to say that from our perspective. Remember, this is the thing that we were just talking about, the rain as seen from the woman's perspective. We're saying that the x value is the same as the y value. Maybe I shouldn't have said x and y. Maybe I should say I and j value. I think that's probably a better way to say it here. So we know that this bit is true from that. Okay, so it's our first little thing over here. And then we'll just do the exact same thing, except for this one here. So in this situation here, what it's saying is that it is a little bit steeper. I'm going to try and draw it. It's saying that this bit here is 30 degrees from the vertical. So I'm taking that to be the vertical because that is what it seems to say, which would mean that this bit is 30 here, and it would mean that this bit is 60. Okay, so remember what we think is, we think that this is not think, but it is. This is our x value, and this is our y plus 3 value. Okay, this time they're not the same as each other. Okay, they aren't. Now remember, x can be a negative number, and in fact it is, and y plus 3 is a negative number, and that's fine too. So what we're going to do now is we are going to be able to say a little something about this. You can do it as simultaneous equations, but actually if you just look at part 1 there, it's already been done for you really. It tells you what x is. X is y plus 5. So, you know, you can just say that this guy is y plus 5 there. So there will be no problem with that if you want to do it. But what can we say? We know the opposite. So we're going to say here the opposite and the adjacent. So tan of 60 equals opposite, which is y plus 3 over the adjacent, which is x. You can write down x, or you can just go straight to saying y plus 5. There will be no problem doing that thing at all. Okay, what now? What now? So we can say that y plus 5, zoom out a little bit, multiplied by tan 60, important to have the bracket the whole way around, is equal to y plus 3. So tan 60, I've lost my calculator, I think it is root 3. The calculator has gone walking, of course. So I have it here. Just want to make sure, otherwise I have to restart the video. We don't want to do that. Tan 60 is, yeah, root 3. So what do we have? We have root 3 amounts of y plus 5 amounts of root 3, and that's equal to y plus 3. Y's all to one side. Root 3y minus y is equal to, and everything else the other, 3 minus 5 root 3's factorize a y. We will end up getting a root 3 minus 1, and it's equal to 3 minus 5 root 3's. So y is 3 minus 5 root 3's over root 3 minus 1. Wonder if that can be written as a nice number. A little bit of maths for us. How do we rationalize the denominator? How do we get it so that there is no root on the bottom, or potentially no root on the bottom? Do you know? Just give me a second to think. Multiply top and bottom by the conjugate of the denominator. Okay, so top by top, bottom by bottom, or you know, just type it into your calculator. But whatever. We have 3 root 3's minus 3. Now what's that? That's going to be minus 5, and it's going to be root 3 by root 3, which is just 3, so minus 5 by 3, that's minus 15 in my book, and that's minus 5 root 3's there. And the bottom, this was the whole point of doing this. Root 3 by root 3 is 3. We do plus root 3, we do minus root 3, and we do minus 1. Yeah, so y is equal to, on the top we have minus 2 root 3's, that's 3 root 3's minus 5 root 3's, minus 18. And on the bottom we just have 2, and 2 does divide into the top quite nicely. So we have minus root 3 minus 9. I hope I did that right. I'm just going to double check it on the calculator. 3 minus 5 root 3 over root 3 minus 1. Oh no. I was close. If that's any consolation to me, and it's not. What did I do? That was a plus 3. That was a plus 3. Sorry, 3 by root 3 is 3 root 3, and 3 by 1 is plus 3. So sorry, that should be minus 12, and yeah, that makes minus 6. And is that the right answer? That is the right answer. So y is equal to minus 6 minus root 3. What was x? Remember, x was y plus... x was y plus 5. Y plus 5. So x is y, which is minus 6 minus root 3 with an additional 5 added onto it. So x is, what's that, minus 1 minus root 3. So there we have it. That's that. That is what the rain is actually doing. Okay, that's not as seen from her perspective or anything like that. That is what it is actually doing. So, what it's doing is it's moving over some amount and it's going down a bigger amount. So like roughly doing that. And it's moving over -1 minus root 3. Okay, that's what we have on the left. So it's actually moving over 1 plus root 3, if you like. And it's going down 6, 6 plus root 3. But if we want, we can leave it as minus. Okay, that's just where it will be on the negative scale. Down here, that's where it will be on the negative scale. If you're measuring the actual distance, remember, distance would be positive. It doesn't really matter for the magnitude. I think that's what we were asked. I'll just flick back here. Sorry to be jumping. By magnitude and direction, we will do both. Okay, so it's just Pythagoras' theorem. So the magnitude of this thing here, and what was this? This was the rain, I think we decided to call it. So it is equal to -6 minus root 3 squared added to -1 minus root 3. Of course, you could just have them all positive, and they will be once it's squared. So, we have a lot to write out. Okay, let's do it anyway with the calculator. -6 minus root 3 squared added to -1 minus root 3 squared, and it's the square root of that whole thing, and it didn't give us a nice number. Kind of getting used to that with this question. It just says to me 8.2, so that's our magnitude, 8.2, and it asks us what direction is it going. So we will get our little direction here. So again, we're dealing with opposite and adjacent. Now, just on a technical point, we should call this pluses. Why am I doing that? I'm just saying that, like, if we moved over 3, okay, so like if we were at -3 and we moved down, I don't know, 5, if we're at -5, if I'm going to measure this angle in the triangle, you know, I don't say, oh, this side is -3, I say it's 3. I don't say this side's -5. I say it's +5. So just be careful when you're doing that. You know, in this case, they were both negative, so that's fine. But if it was like, if it was -5 plus root 3, you would have to say then to take a physical distance. You know, this is an overall negative number, at least I think it is. Yeah, of course it is. If you wanted the actual distance, you would say it is 5 minus root 3. So it's all of it that has to change. In this case, it's that. What are we saying? We're saying tan theta equals opposite 6 plus root 3 over the adjacent, which is 1 plus root 3. So let's do that. Tan inverse 6, yeah, let's try that again. 6 plus root 3 over 1 plus root 3, close brackets, syntax error, the bracket got cut down below rather than doing the whole thing, and there we have it saying 70 degrees is what it's saying there. So that is going to be, well, there's a few ways to write it, I guess. It's going to be what, west 70.539 degrees south. We could say that. Is that right? That is right. Yeah, I think that is correct. Okay. Just make sure that that is what it's saying. You see, I'm just hesitant here for a second. Find the direction of and the velocity of the rain. Okay, magnitude and direction. So we have that, but what I think they were doing, just out of good manners, what they were saying was with the vertical. Okay, they were giving that angle with the vertical. So I think what I was doing, you'll have seen just a little bit earlier, if this is, I'm just going to call it 70 for the moment. If this is 70 here by that, what they were using to measure it was they were getting that little angle there. So I think it might just be good manners to just say that it's 20 now. Obviously, it's not exactly 20. It would be 90 minus the previous answer that we got. So 90 minus ANS. I would think just to write it like they have, you could also give it as 19.46 degrees. What did they say? From the vertical? Was that what they said? With the vertical. Okay, an angle of 45 degrees with the vertical. So an angle of that with the vertical. I would imagine you would get marks for both. But if they've written it one way in one question, you know, in a particular question, I would stick with that format. I think that's just sort of the accepted thing. It's kind of like in languages, you know, if the question is in French, you're meant to give the answer in French. If it's in English, give it in English. I think that's true. Check that with your French teachers, of course. So that is the B part, which you can see there. So just a quick little recap on the whole thing. It is similar to ones that we have before. Start off with giving the rain a name, so x plus y. We're given one case of falling by 5, and then what you do is you get the rain relative to the woman, and because it's at 45 degrees, you can say that the x value or the I value equals the j value. So in this case, x is equal to y plus 5. Case 2, which I've then drawn a nice little diagram of, if I do say so myself, which is our little 30 degree one, and then you just build up what the rain is doing from that using tan. Okay, using tan. And you have a simultaneous equation. We already know that x is equal to y plus 5, so you can just sub that straight in for the x value and solve it out there for what y is. So y turns out to be not the easiest thing in the world, as is x, but we get it. We have our x value, we've got our y value. Do the magnitude, that's just Pythagoras' theorem, and get the angle, that's just tan. Okay, that said, you know, that's still a reasonably tough question, and especially if you have been a bit lax with the videos, something like that, or you weren't doing every single example that was there, you know, you now get to see that there's plenty of parts where if you don't have specific knowledge, you're going to fall down. Remember that relative velocity, I mean, everybody does it, but it is one of the most poorly answered questions. Okay, it is one of the lowest response rates. If you check out the chief examiner's report, and I really do suggest, you can see what are the most popular questions, but which are the most poorly answered. This one tends to be down on the floor. So if you want to like distinguish yourself from other people who are doing applied maths, this is really one to focus on. Anyway, gents, hopefully that was helpful. Any questions, please do ask. That's what I'm there for. I know that a couple of you got in touch to say that you found that one particularly tough. So do go over the question again and retry it, okay, even after seeing me do it. Okay, gents, take care. All the best.